Hello, this is Ozan, and in this video, I'm going to explain my Seesaw Simulation project, so let's dive in. Firstly, I want to talk about the UI part and the things I've considered. For the UI, I decided to build a screen similar to the example project. As you can see, we have the statistics at the top, the left weight total, right weight total, the next weight, which is generated randomly between 1 and 10, and the tilt angle. After that, we have the seesaw part. There's a clickable area with the same width as the plank, and if user clicks anywhere outside this area, it will highlight it. User can hover over this area to see the preview weight and where it's gonna drop. And when we click, the weight will drop and with the drop sound, and the plank will tilt based on the torque calculation. So let's see it. And there are logs showing how much weight dropped where. And while I was reviewing the example project, I was trying to find some edge cases which I should pay attention, and there were exactly 9 log messages at most. So in this log container, it will show 9 log messages at most. And I implemented the local storage feature so that when we reload the page, the last state of the Seesaw will be reloaded. So let's see it. Yes. And there's a reset button that resets the Seesaw. So let's look at the code. So the goal was not just to make it visually work, but to design it with clean structure. So I structured the project with the separation of consoles in mind. We can see the HTML file here, and the important part is I added 2 empty divs to see the preview weight and line. I have this CSS file for styling, and under the logic folder, we have all the JavaScript files. We have the DOM selectors in here, and all the constant values to prevent the magic numbers. So the weight class is responsible mainly for rendering and visual representation, and there's the getSize function. This function calculates the size of the ball based on the weight, and while I was reviewing the example project, I saw that the base size for the 1 kg weight is 34 pixels, and every kg is adding 4 pixels more, so I calculated in that way. And then we have the state.js where I store the weights of the state. Also, the local storage functions are declared here, and I wanted to store only the major variables like the location, weight, and color of the weight object. So I'm storing those in local storage. Moreover, I wanted to separate the physics calculations from other things. So here I am calculating the angle and the torque. To prevent unrealistic behavior, I clamped the rotation between -30 and +30 degrees here. After that, there is the main.js file. The main functions are here, such as update totals and angle, restore simulation for loading the state from the local storage, and the event listeners for the preview ball to track the mouse is here, and the dropping weight on click or resetting the state with buttons are declared here. The most important part here is these lines. As you can remember, there are divs only for the preview ball in the HTML file. Here I am cloning that element, and with the load weight function, I am creating a real dropped weight on the state. Furthermore, in utils.js, we have other functions like getting random weight and color, getting middle point, and playing the drop sound on click. Last but not least, the log.js handles adding long functionality. As you have been seeing, I tried to use the command lines throughout the project in order to make it more understandable and clear. Overall, I try to approach this project with a clean architecture mindset rather than just making it visually functional. So thank you for watching.